Hey everybody, thanks for coming. I am going to be talking to you a little bit about our specific journey into AWS cloud modeling and actually what does that even mean. So we're part of the VMware Cloud Services portfolio now. We were a startup, but effectively we're trying to help our customers do as much as they can in any cloud, be it on-prem or hybrid or a specific public cloud. And my team, the secure state team, is helping along the security aspect of that. So I'm going to get into it pretty quick here. Feel free to ask any questions along the way. I want to keep it kind of open. But I'm going to talk about who we are and why you should listen to us. Then I'm going to introduce you to a sort of a novel data layer that we had to create in order to make our product come alive. And show you how we actually created the Amazon model inside of our data layer. So who are we? We were a startup. We were Cloud Choreo. I started the company 4 years ago. February, VMware acquired us. The reason I bring this up is I don't want you to think we are new to this. Secure State is brand new. As a matter of fact, the branding turned to Secure State on Friday. So we're like, I don't know, 3 business days old, technically. But our team has been doing Amazon architectures, cloud architectures for a long time. We have guys directly from Azure working on our team, even though it's not that big. We have guys from AWS on our team. One of our people even helped design S3 back in the day. I've been doing Amazon architectures for over 9 years, almost 10 years now. We've got NASA JPL guys, and again, even though we're small, we actually have 3 successful startup exits behind us, all in the cloud security or network security domain. So we've done it before, even though it's a new service. And so why did Cloud Choreo exist in the first place? This is kind of the statement that said it all. 80% of all cloud breaches by 2020, they expect will be from misconfigurations, basically preventable issues. Not your data, not your container hacks, not your host hacks. It's literally just we screwed up with our configuration. Right? And why does that happen? It's because everything is API driven. There's a lot of complication behind that. People will turn on access in order to get their job done, and then they'll leave for dinner and forget to turn on access back off. It's really simple things that happen. And to be honest, we saw the entire cloud security industry as a failure. We look at the current state, and you can find various products out there. They're all looking at attributes on an object in your cloud. They'll look at an S3 bucket and they'll say, oh, that shouldn't be open to the world. Great. That is accurate. But the issue is that there's no application awareness. There's no context behind that alert, that violation. So you get lost in the sea of alerts. A lot of our customers would have 6, 10, 15,000 violations in the standard reports, and it was just totally well, you couldn't even read it. You can't read the report when it's that big. So we came along and we said, how do we fix that? The big thing we wanted was speed. So we wanted real-time alerts. And that turns out to be very difficult because if you set up an event stream, all the clouds have them, you start monitoring your event stream, the objects that come in, the things that get sent to you, you don't know the context around those. So for instance, if I open a security group up to the world, maybe all ports, all traffic, is that a violation or not? I mean, everyone out there would say yes. What we say is yes if it's connected to a server, right? And there's a big distinction there. We still don't think you should be doing it, so we'll flag it as a low thing, a low violation. But unless it's connected to a server that's actually doing work and has credentials and actually has code on it, then to us it's not a high violation. It's like, don't wake you up in the middle of the night for that. So we decided kind of the only way to figure this out was to understand the entire context in which that object lived. And that was easy. All we had to do was build a full model of your entire cloud ecosystem and keep it up to date in real time. Simple. So we started to do that, and we created what we call Rosetta. Rosetta, from optics point of view, is a graph database, but in reality, it's a totally self-sustained service. It's decoupled entirely from our secure state application. It's a generalized pub/sub graph database with plugins that anybody can create in order to adapt event streams into subgraph units and insert them into the ecosystem as a whole in a transactional way. So adding to that, you can take any sort of definition of any query, I should say. In secure states realm, a query is a violation, a security violation. You can register any query with Rosetta, and on state change of the results of that query will notify the application that registered it, or any other endpoint you want. And so what that gets you is this giant, and we also have a search a just-in-time API that lets you explore your data set. But what the alerting gets you is this ability to find a needle on a haystack, so to speak, when an event comes in. So if an event comes in, we update that one node, we run your rules against the entire data set, and we find out if that new update just created a violation. And again, our goal was real time, so the entire process, this is from a few days ago, we aim to be in under 10 seconds from the time an API call is made to Amazon to the time we get the alert out the door. And this is right from our Grafana dashboard right now. We're hovering in the 4 to 6 second range right now. Trying to get it faster, but we're trying to get, we actually state under 10 seconds. So we're doing pretty well. The bread and butter behind this, or the kind of the most important part, in my opinion, is this plugin architecture we've created, where you can create these things we call domain model plugins. And the reason we call it domain model is you kind of have to be the master of your domain to write one. We've written the one for Amazon. We've written the one for Azure. We're working on VMC. We're going to work with the guys at VKE to do the Kubernetes one. But the idea is pretty simple. You can write a chunk of code in whatever language you want. We expose a few APIs in outbound, so you can update models, and we ask you to, we force you to expose some APIs inbound so we can do a few things. The two most important things we do inside your code is we have a cron service that we will initiate a method inside your code every 24 hours. The idea being or you can do anything you want with that, but what we do with the Amazon model is rescrape your entire cloud inventory every 24 hours to get anything that events don't exist for. We also have a process event endpoint that you must implement, and when an event comes in, we stream it right to your code. It's got to process it and shoot it out the send nodes API. So that's kind of it in its entirety. Like I said, we've created it for AWS and Azure already. Actually, the AWS one's written in Ruby. The Azure one's written in Go. Implements gRPC on both sides, so anything that supports, which is, 10 or 15 languages at this point, you can write it in. All right, so this is code. So let's start talking a little more technically. The domain model itself is pretty flexible. We force you to create, or we force you to add I guess it's 5, but in this it's 3. We force you to create three properties on every single object that you're sending to us. Those are label, object ID, and location. And they are on purpose not mentioning anything to do with cloud. So if you wanted to create a domain model plugin that is indexing and analyzing the Google Docs inside your organization, you can completely do that. The list of properties is typed. That's on purpose as well, so that you can go and write your own queries in a efficient way. And we take care of all the indexing and inserts and stuff like that for you. Yeah, at this point, I was going to show you an example of Amazon and why it's so difficult. If I can get out. Okay, so yeah, I'll just start. So if we start looking, if you want to start creating a domain model plugin, literally we can do it with any data set that is API driven publicly. So obviously AWS is. But if I start in the bucket area, the S3 area, and I run a list buckets, I can see here, we have a whole ton of them. This is our test account for actually creating failures on purpose and things like that. But if I come in and I ask for just one, I can look at it, and effectively in a JSON return, anything in squiggly braces becomes an object inside of our node. Okay, so if I start looking at this, just take some notes here. If I start looking at this logistically, what I would want to do in this case is create a node inside of Rosetta that's called a bucket, because I just listed buckets. So if we remember the data model, I've said you have to create a few things. You have to create properties that are label, so we'll add a label, right? Bucket. You have to create a object ID. So we'll call that, the name. I'm P. Allen, that's why. And this is a failure mode bucket. So. And we have to give it a location. And location can be anything. Again, like if you're talking about vSphere or something, you'd probably pick your actual, whatever you've named your data center or something like that. Or it could be rack or anything. So location, we'll call it US. Right. So now I've got a fully, this is actually a fully compliant object inside of Rosetta. You can send this over and it'll create the node. Doesn't really have much going on, but it will be there and you can search for it and you can alert on the thing. So you could actually, technically, well, there's actually nothing on here you can modify inside of Amazon. So it's a bad example, but you could create rules that actually get triggered off this thing. So now it gets a little interesting if you start adding more data to it. So now what I'm going to do is I'm going to go and I'm going to look at the access control list for this bucket. So when I run that, it becomes a little more complex, right? So this is a single API call, but if you remember what I said, every single curly brace is its own object, right? So this is an object. The grants object is a list of these grantee, or I should say, a list of grants, right? Grants is a list of grants. So if I want to take these things, I can come out here and I can start manipulating them again. I can come in and I can say, all right, well, I have a list of grants, so I know that this thing is going to be a label of grant, and it's got a whole bunch of these things in here, one of which is a grantee. Grantee needs its own object as well. So I can come out here and I can say, all right, now this is a label of grant, and so on and so forth. So you can see it gets pretty complicated pretty quickly. The interesting part happens when, sorry, this is OCD kicking in. The interesting part happens when you want to start creating the connections. So if you look back here at the model that we've created, or the example I've got, we have the label, object ID, and location that I've already gone through, but then we also have a list of properties. So every single one of these properties needs to get converted into anything that's not the label, object ID, or location needs to get converted into one of these properties arrays. So display name would actually become an array entry with a tuple that's type and value. So type would be string, value would be Paul plus dev, right? So I'm not going to do that work in here. But the next interesting thing is the connections area. So connections is actually just how you create bidirectional relationships inside of the Rosetta data structure. So if I come in here and I look at this original, if I start in the nested tree of the original API return, right, I can say this grantee is sort of, in a way, it's its own object, but it's also in relation to this API call. Right, so this object in its entirety is a bucket ACL. That is what it is. So you would have a bucket ACL node, and in there, you would create a connections object. So if I had a, type bucket ACL, I could actually create this connections array and now I just literally take the object that I generated for each one of those nested things and I jam it in there. That's all you have to do. You just take, so I just take this grant, right? And you can look over here and see that connections is an array of objects. So I can take this grant and dump it into my connections thing for the bucket ACL. And I can have any number of those. And when you post that up to when you gRPC that through the API call, that'll actually get inserted into our data set and inserted into your data set in its entirety in the right place and create the bidirectional relationship inside the graph database. What happens in the background at that point is because we know the label's grant, we know the parent is bucket ACL, we know its parent then is bucket, we're going to go and check every single rule you've got that you've registered for anything that references a bucket ACL, a grant, or a bucket. And we're going to run those rules on the data set at that moment. So these all get inserted as a single transaction. Then we go and we say, okay, what types did we just insert? And we'll run every rule you've got registered against that and send the notifications out if appropriate. So that was a lot and fast. You guys have any questions or? Cool. All right, so I'm happy to talk more about that. I'm conscious of time here, but the actual system that we created does this for every single API call that Amazon has. It's about 6,800 of them. And it creates your graph dynamically. So when you sign up for Secure State asks Rosetta to go and run that cron job for the first time. It'll go through, using the credentials that you provide us, it'll go through every single service and every single API call in this service. It's a get, list, or describe. And it'll populate the model for you. And actually not that much time considering how much data we gather. And then you can set your event stream up. And as every event comes through CloudTrail, every API call you make will get funneled into us, and we will do exactly what I just talked about with every API call. Yeah, so that's what we call smart discovery and API discovery. So we're actually using the SDKs to auto-generate our code. So whatever Amazon puts out in an SDK, auto rolls out in our container. It updates all the API control, the API calls automatically, generates the relationships automatically, and then we start running your inventories every 24 hours and ingesting your streams. So again, the domain model plugin is everything we just talked about. Is kind of that middle section right there, converting your API call, your JSON, into a graph, a subgraph that automatically gets inserted into your data set, and we can trigger off everything. So that's basically everything I have. I was going to save some time for some Q&A or if anybody has any questions. No? All right, cool. Well, these slides I had to put in, so it's pretty easy to get started. We do have a sign-up page right on the cloud.vmware.com/secure-state. You can go in, you can hook it up. We are running a bunch of VMware accounts already. And yes, we found a lot of high violations that need to get remediated immediately. But they're all test accounts. So yeah, please, I guess, head to Cloud City. Yep. And yeah. Cool. That's all I've got, guys. Thank you.